Let's start with a video clip on the inclined plane and then I'll explain.
Then there's a program on the lever. Next comes mechanical advantage and friction. Then the screw and the wheel. And finally, the pulley. But our story begins with the inclined plane. You haven't really got enough force to lift that barrel, have you? How much force do you need to lift it? Well, how much does it weigh? So you'll need at least 800 newtons of force to lift it into the back of the truck. How far is that? About 1 meter? How many joules of energy will it take? Well, figure it out. Energy is the ability to do work. Work equals force times distance. 800 newton meters of work, or 800 joules of work, which is the same as 800 joules of energy. But you still can't lift the barrel. There's something wrong somewhere. Perhaps it's because you have to exert your energy all at once. If only you could load the barrel onto the truck a little bit at a time. If you could slice it into 4. Then you'd have 4 200 newton slices of barrel. And you'd only need 200 newtons of force to lift each one. That's easy, isn't it? You're using your energy more effectively now. You're spacing it out over a longer time. But you don't get anything for nothing. Although your force is cut down to a quarter of what you need to lift the complete barrel, each time you lift a quarter of the barrel, you exert that force through 1 meter. Which means that you lift the 4 quarter barrels through a total distance of 4 meters. What you're winning on the force, you're losing on the distance. It's a sort of trade-off. The greater the distance, the less force you need to exert. Very neat. But you can't go around breaking things into pieces just because they're too heavy to lift. If only you had a machine that would allow you to trade increased distance for decreased effort or force. Here's your machine. Yes, I know it's just a plank, but it's also a machine. Try and get the barrel into the back of the truck now, and you'll see why. Magic, isn't it? No, it isn't. It's exactly the same trade-off you got when you split the barrel into 4. The plank is 4 meters long. Instead of moving the barrel 1 meter by lifting it straight up, you're moving it 4 meters by pushing it along the plank. You only need to push it with about
Well, let's see if I can explain this for you. Let's pull up the PowerPoint. So today we're going to talk about the inclined plane, or sometimes called the ramp. The Egyptians years ago used to use the inclined plane or the ramp. So here you can see the different kinds of slopes that they used to use to get things to the top of the pyramid. And here's some examples of inclined planes or ramps in houses. Stairs are inclined planes. And here's a ramp that we use to get wheelchairs upstairs. Let's talk about the inclined plane in regards to mechanical advantage. Okay, we know the mechanical advantage of several simple machines already, the lever as well as the pulley. And so let's look at the inclined plane. To find the MA, we need to again look at the following. The length of the slope divided by the height gives us the mechanical advantage. So let's say that this ramp was 15 by 3 meters tall. The MA would be 5. Let's talk about some other examples of different versions of an inclined plane. A screw is simply just a cylinder with an inclined plane wrapped around it. And so here are the threads to the screw. So a jar lid, a drill bit. These are examples of a different version of an inclined plane. Also, wedges are using inclined planes. Basically what a wedge is you take two inclined planes and you join them back to back. So an axe right there, zipper, and so on. Let's talk about work again. We know from our previous video about work input is the amount of work done on the machine. So in the case of an inclined plane, it would be the amount that my cursor is going up. And in the case of work output on the inclined plane, it would be here. So let's look at this box. The box is 10 newtons. If I lift it to the top of this up here, how much work have I done? Well, force times distance. So 10 newtons times 3 meters. What would that equal? 30 joules. Okay, well, let's say I put the box over here and I dragged it or pushed it up the slope of the inclined plane. Well, now I wouldn't be putting in 10 newtons of force because the slope of the inclined plane helps me reduce the amount. So remember, the MA is always equal to whatever your output is divided by whatever your input is. So we know the output, it's 10 newtons. And we know how to find the MA. We take 15, the slope, distance, 15, and we divide it by 3, which is the height of the ramp. And what is that? 15 divided by 3 is 5. The MA of this ramp would be 5. Okay, so let's say MA is output over input. So 5 equals 10, which is the output, divided by whatever we put in. So 10 divided by what equals 5? 10 divided by 2. So if we push the box up the ramp, it would only require 2 newtons. However, watch what happens. When we push it, we have to push it over the distance of 15 meters. So what's the amount of work on this side? Force times distance. So the force now is 2 newtons times, this time, the distance of 15 meters. Hey, look, just like every other simple machine, 30 joules, the same as over on this side. So 30 joules if we do it this way, 30 joules if we do it this way. The benefit to doing it on the slope of the ramp is it only requires a measly 2 newtons. The drawback is we have to push it 15 meters. Let's try this problem. So we have a 30 newton box and we want to lift it up to the top of a truck, let's say, that's 3 meters high. Okay, here's the same box. If we put it on the ramp, we could drag it up the ramp. How much effort would it be to drag it up the ramp? Well, what do we know? Let's find the MA. For a ramp, the MA is 9 meters, because that's the distance of this slope here, divided by the height of the ramp, which is 3. 9 divided by 3 gives us an MA of 3. Okay, let's go back to our second MA formula, which is output force divided by whatever the input force is. We know the MA, that's 3, we just found that. We know that the box is 30 newtons, so 30. We just don't know what the input force is. In other words, how much effort to push it using the ramp. It's not 30. Okay, it's not 30. So 30 divided by what equals 3? 10. So 10 newtons is how much effort it would take for us to drag it up the ramp. How much work is being done in this problem? Well, there's two places we can find that. Here, how much work just to lift it without the simple machine, or we could find how much work if we use the simple machine. So 10 newtons over a distance of 9 meters. Okay, so force times distance here. Or 3 meters, but we have to lift the entire blocks with 30 newtons. So force times distance here. So what's the force here? 30 newtons. What's the distance? 3 meters. What's that equal to for work? 90 joules. How about on this side? What's the force? 10 newtons now. What's the distance? 9 meters. Still 90 joules. The same. One more example. Here's a guy and he's got a barrel. With the inclined plane, it takes 10 newtons to push the barrel up. Without the inclined plane, so if he just does it straight up right here, it takes him 20 newtons. So let's figure some things out. What's the MA of the inclined plane? Well, it's the length of the slope divided by the height of the ramp. So what is that? 4 meters is the length of the slope right here. The height is 2, so 4 divided by 2 means the MA is 2. How much work is being done? Well, we could find work here, force times distance, so 2 meters times 20. Or we could find it here, 10 newtons times 4. So let's see, F, force times distance, for input should equal force times distance for the output. So that's 10, and this is times 4, or it's 2 meters times 20. And what do they both equal? 40 joules. 40 joules. So that gives you an idea of some things we need to do for the inclined plane.